Simplifications of context-free grammar.
This video is subject to copyright owned. To maximize the use of this session, please connect a headphone and mic if you can. Stay in a quiet place. Adjust the sound of your computer. Close all other programs running on your computer. The instructor will direct you to open any other required program to use. Close chat programs and social media such as Facebook, Twitters, Messengers, WhatsApp, etc. Maximize your screen to see the four corners on this slide on your screen.
We are continuing the previous session where we would like to talk about how we can build a more canonical form or to build a simple form grammar. In this particular example here, we have a grammar where we start with sentence S and S lead to A small b capital, and then A will lead to small a and the symbol capital A again, and then A may be leading to A small b small terminal and B capital and C. Remember, the small alphabet means a terminal, and the B mean the capital alphabet means a sentence or an expression. So we have here two definitions for A's, and we have also two definitions for B's, and we can see that they are connected, the big A, the capital A with the capital B. In this particular grammar, if we substitute the capital B with small b, this will lead to that S could be leading to A capital B or small a small b. Similarly, we will substitute B in the second expression to small b as terminal, and this will be the equivalent grammar. If we take the equivalent grammar and we substitute capital B with small a capital A as sub-expression, S will lead to the following equivalent grammar, where S can be capital A, big B, capital B, small a, small b, small a, and capital A. And the same thing for A could be to A double A small a capital, and A could be capital A capital B, and sorry, small a small b capital C, or small a small b C, or small a small b capital A capital C. From this equivalent grammar, we also should be able to remove the term A, B, and in this way, and we will remove the term A, B, C. So in this way, A will lead to X, B, capital Z, and B will lead to Y, 1, and then from substitutions, A will be equivalent to the same grammar. We spoke about the nullable variable, or the lambda variable, or the lambda protection. Nullable variable means empty. So if I want to have the nullable variable, so X will lead to nullable means at certain point the variables will end up to be nullable. For example, here Y will lead to nullable lambda. For example, if I have S will equal to A capital M B, while M will lead to small a capital M and B, then capital M will lead to null production, which means a terminal or a termination of the expression. If I want to remove the null production here, for example, I can substitute the actual variables with the end results without just two terminals. So I may say M will lead to A M capital B, where M could lead to null. In this case, I can substitute, so M will lead as a terminal A, small b. If I want to remove this, I will go into the substitution, and this will be the equivalent. So after we remove all the null production, all the nullable variable disappear except the start variables. So no variable will lead to null. There is also the unit production, and the unit production means a symbol will lead to another symbol. So a sub-expression A capital can lead to B capital, and B capital can lead to A capital. So this both sides will be leading to the same expression. Removing all of this unit production will give you this example here. So you have S will lead to A, small a, capital A, and then capital A will lead to terminal A. A can lead to big A, to capital B, sorry, and B capital will lead to capital A. Then B can lead to A and B. If you notice here, this means A and B are equivalent. So if I substitute A by B, I will be, if I remove this, I will say A equal to A or B. And then when I remove this as well, it will lead to, here we are trying to do it step by step. So it will lead to this particular expression where I remove B from here. And then when I remove the second part from the nullification, it will end up having the substitutions in this way. And if you notice here, you have two similar expressions. So you basically can simplify. So the final grammar here will be S can lead to A small a capital or A small b, where A can be A or B can be double B small. So this is particular final grammar for the original. We can also talk about useless production. In this case here, some derivative never terminates. This is a production where you can always have a replication, so it will never terminate. It can always keep moving on and on. So you can have S, A, small a, capital A, small a, double A, and you can keep going. And it will never in reality ends, because you don't have A as lambda. So in this case, this grammar will never conclude to an expression, because you have this is as useless production. Here we speak about another grammar, and in this grammar you have B, which will terminate to B capital A. This is not reachable from S, because S will be leading to A, and A will be leading to A. A can be leading to lambda, so this is a complete grammar here, while B will never be reached from the starting terminal S. So in this case, this we call it also useless production. In general, if there is a derivative which is S can lead to a different variables, and which will end up leading to omega, and omega consists of all the terminal, then A, it's a useful production. Otherwise, A is useless production. So the trick here is to have from the start getting all the intermediate intermediate expressions capitals, and at certain point these capitals has to reach a terminal point. So one big question can come to the exam where somebody will say a production A lead to X is useless if any of its variable is useless, which means here you can have starting from S, S will come back, then S will lead to A, then A will lead to A, and you can keep iterated here while you never reach B or C or D. So in this particular example, these variables can be useless. So these are the useless variables in this particular case, and these productions are useless productions. If I want to remove useless variable and useless production, I have here an example for you, and you can go through the example where starting symbol S will lead to A, S, A, or capital A or C, and A will lead to small a, B will lead to small b, small a, and then C will lead to an A, C, B. So in round one, you have the right hand side productions is only terminals, so these are only terminals. In round 2, the right of production has terminal variables, so this process can be generalized. So we find all variables that can produce strings with only terminals or lambda, and then what we do is we remove the production that uses variable other than a, b, and s, because a, b, and s are the only production. So this particular grammar will lead to a variable grammar. Then we talked about reachability. So because remember, when we talk about useless, we talk about two things. One is you will never reach the status, which is basically not reachable, or you will not conclude with a terminal. So here I have the variable reachability. I can check the reachability using a state diagram. So I start from the symbol S, and then I will reach A. And as you see here, you have S going back to S, or substate A, or I will have A will lead to A, then B will be AA. So I will be basically remove the non-reachability from S. So in the steps are, first step is to remove nullable variables. Second step is to remove unit production. Third step is to remove useless variable. This sequence guarantees that unwanted variables and production are removed. So the way we have these questions asked is you will be basically given a set of grammar, and it will ask you to remove or to simplify this particular grammar. Normal forms for context-free grammar. Chomsky normal form, that each production has A will lead to two variables, or A will lead to a terminal. So in this particular production, we will guarantee that you either go to two variables or you go to terminal. You never have a mix of variables or terminal. So this is the example of the Chomsky normal form, because each one will lead to two variables or will lead to a terminal, and then the variables will lead to other two variables and terminal. However, in this particular example here is not a Chomsky normal form, because you have here a variable leading to three variables. So this is not Chomsky normal form. This also is not a Chomsky because it leads to two terminal. The examples which we'll see here is how to convert to a Chomsky normal form. So I will be giving an example like this example, where S, for example, will be capital A, capital B, and small a, and then A will lead to small a, small b, and then capital B will lead to A, small c as terminal. Can you convert this to Chomsky normal form? We introduce new variables for the terminal. So each one of these terminals, A, B, and C, will have new variables. This is the first step. And then we substitute with these variables here inside the actual grammar. Then we will introduce an intermediate variable V, and to break the first production, we will take A, B capital with TA, which is the terminal, and we will replace A, B, and T with the variables, and then the temporary variable 1 will be equal to B, TA, and we keep repeating this through V2, and then the initial grammar will be S equal to A, B, small a. Capital A will be equal to or leading to small a, small b, and then variable B, capital B will lead to variable A and terminal C. In this case, I will have the S will be leading to the variable V1s and variable V2. I added terminal A, and this terminal A, B, C will lead to the terminal A, B, and C. By introducing these temporal variables or dummy variables or whatever you call it, you will receive here the Chomsky normal form. From any context-free grammar which does not produce lambda and not in Chomsky normal form, we can obtain an equivalent grammar in Chomsky normal form. The procedure is remove first the nullable variables, then the unit production useless variable option. Then for every variable A, you introduce a terminal A as T capital A, and you add the production from T capital to A. And in production with length at least 2, you replace A with TA. The production of the form will lead to terminal A, does not need to change. And then we will replace any production A, C1, C2 to Cn with the dummy variable V1, where V1 will lead to C1, V1, and then V1 will lead to C2 and V2, and you keep going till you reach the terminal Cn minus 1 Cn. Then the non-intermediate variables will be presented. Chomsky normal form are good for parsing and proving theory. It is easy to find the Chomsky normal form for any context-free grammar. At this point, we will introduce also another Greenbush normal form, and the Greenbush normal form will lead to that any variable will be a simple terminal and set of variables. So this is the Greenbush or Greenbush normal form. Here I will have the starting S will lead to a terminal plus 2 different variables. Then the variable will lead to a terminal plus a variable, a terminal plus a variable, or a terminal, and then a variable will lead to a terminal. So this is what we call it the Greenbush normal form. You can have the non-Greenbush normal form in this example, and the question will be, given the terms on the left hand side, can you remove it to the Greenbush terminal form? The answer will be yes, because I can take B terminal and move it to TB, while TB will lead to B. And then I can take the second B terminal and delete it to TB, while it will lead to TB. Then I will take the symbol S, which is leading to A, and I'll take the second A and move it to temporal terminal A, where TA will lead to A. So in this case, I will build here the Greenbush normal form. The observation I have here is a Greenbush normal form are very good for parsing a string, better than Chomsky normal form. However, it is difficult to find the Greenbush normal of a grammar. In this particular session, we covered 2 different normal forms for grammars and languages, and they will have different functionality, which we can explain later. If you have any questions, please email them to me at the email in front of you, badawi@kaiwave.net, or leave the comment below, and I'll be more than happy to get back to you.